Now we're on to example 6, looking at even harder things. Find the domain of f of x is equal to quantity x squared plus 2x plus 1 over x squared plus 5x plus 6. Okay? So remember, the domain of a function is the set of all things that I can safely plug in without getting division by 0 or square roots of negative numbers. Usually. There are more complicated functions than that will cause other places where it's going to be undefined. But we're not going to look at those for the time being. We're looking at this guy. So what can cause problems here? Notice I see no radicals whatsoever. So the only thing that can reasonably cause an issue here is division by 0. Notice that I have a fraction, so I have variables in the denominator. And I probably could plug in something into these x's here that's going to cause division by 0. So how do we figure out what those x's are? You're going to set the denominator equal to 0 because we want to figure out what x's are going to cause that division by 0. So we have x squared plus 5x plus 6 is equal to 0. Setting the denominator equal to 0. So now we have to remember, how do we solve quadratic equations? The number one way that we go about doing this is by factorization. We have to factor this, so we have two quantities multiplied to each other so that they give us 0. We need to figure out how we can break this guy down. So when we have a quadratic that looks like this, we want to find two numbers that add to 5 that multiply to 6. Okay? So how do we do that? We need two numbers that add to 5 and multiply to 6. What would they be? Well, that would be 3 and 2. That'll give us 5. And 3 and 2 give us 6. So how do we write this as a factorized form? This implies that x plus 3 times x plus 2, well, that's going to be equal to this. But I'm using an implication symbol just to show the thought process here. And that implies that this is equal to 0. So x plus 3 times x plus 2 is equal to 0. All I did was factor this guy. Okay? And if you want more help on how to factorize different quadratics, there is a section in the pre-calculus course that'll help you do that. So continuing on, I have two quantities that are multiplied together to give us 0. So therefore, either this is going to be 0 or this is going to be 0. All right, so what does that tell us that x has to be? In this case, x can be minus 3. So if I plug in minus 3 plus 3 is going to give me 0. Similarly over here, if I plug in minus 2, that's going to give me 0 in this quantity. So x has to be either minus 3 or minus 2. Remember, the goal here was to figure out the things that cause division by 0. So we set the denominator equal to 0, and we said, hey, look, x can't be minus 3 or minus 2, because if I did plug those in, my denominator is 0. So the domain is the set of all things that cause no problems, and we can write that as a set of all real numbers minus the things that cause problems. Or we can write this in interval notation as follows. I can plug in everything from minus infinity to minus 3, because that's less than minus 2, union minus 3 to minus 2, because there are numbers between minus 3 and minus 2, and from minus 2 onward. Okay? So we're just picking up where we left off in each of these cases. We break at minus 3 because we can't include that, pick up at minus 3 and not include it, go to minus 2 with all the numbers in between, those are all safe, break at minus 2, pick up at minus 2, go to infinity. So these are the set of all x values. You can pick anything that lives in one of these intervals, and you'll be just fine trying to plug this into the function. You will not get division by 0, you will not get square roots of negative numbers, in which case we are done with this example.